Future trend. 3. Technology transformation, AI autonomy and quantum enhancement. From 2025 to 2040, dairy farms will evolve into semi-autonomous ecosystems managed by advanced artificial intelligence, with quantum computing enhancing complex decision-making capabilities and human operators focusing on strategic oversight rather than daily operational management. AI farm management will achieve unprecedented levels of autonomous operation capability. Autonomous daily operations will handle feeding, milking, and health monitoring with 95% plus accuracy, reducing labor requirements while improving consistency and precision of routine tasks. Self-diagnosing equipment will schedule repairs before failures occur, reducing downtime by 60 to 80% through predictive maintenance that anticipates problems before they impact operations, ensuring continuous production and reducing emergency repair costs. Dynamic optimization will enable real-time adjustment of all farm parameters for optimal welfare and production outcomes, continuously adapting to changing conditions and animal needs faster than human operators could respond. Cross-farm learning networks will enable AI systems to share insights across operations for continuous improvement, creating collective intelligence that benefits from the experience of multiple farms and accelerates learning and optimization. Robotic workforce expansion will fundamentally change labor requirements and operational capabilities. Multi-purpose robots will handle milking, feeding, cleaning, health monitoring, and basic maintenance through single units capable of multiple tasks, reducing complexity and costs while improving flexibility. Swarm coordination will enable robot teams to collaborate on complex projects like facility cleaning or animal handling, creating coordinated responses to operational needs that exceed individual robot capabilities. 24/7 operations will enable continuous management without human supervision requirements, allowing flexible animal schedules that optimize comfort and productivity while reducing labor costs and improving operational efficiency. Adaptive learning capabilities will allow robots to acquire new skills through observation and practice, continuously expanding their capabilities and adapting to changing operational requirements without extensive reprogramming. Quantum computing applications will solve optimization problems impossible with classical computing. Complex optimization will enable feed formulation considering thousands of variables simultaneously, creating nutritionally optimal rations that account for individual animal needs, ingredient availability, costs, and environmental impact. Genetic modeling will analyze millions of combinations and environmental factors for breeding decisions, enabling genetic progress that maximizes multiple objectives simultaneously, including production, health, welfare, and environmental impact. Supply chain optimization will coordinate regional dairy networks in real time, optimizing logistics, processing, and distribution to minimize costs and environmental impact while maximizing quality and freshness. Risk prediction will provide enhanced modeling of weather, disease, and market volatility, enabling proactive management responses that minimize negative impacts and capitalize on opportunities. Digital integration systems will create seamless information flow and decision support. Digital twin farms will provide virtual replicas, enabling scenario testing and optimization before implementing changes on actual farms, reducing risks and improving decision quality. Augmented reality management will overlay real-time data for enhanced decision-making, providing immediate access to relevant information when and where it's needed for optimal management responses. Remote expertise will enable global specialists to provide guidance through AR and VR systems, making world-class expertise accessible to farms regardless of location, while reducing consulting costs and travel requirements. Blockchain integration will provide secure, transparent tracking from farm to consumer, creating immutable records that support quality assurance, traceability, and premium market positioning. Advanced sensor networks will provide comprehensive monitoring capabilities previously impossible. Molecular-level sensors will monitor air, water, and feed quality at unprecedented precision, enabling immediate responses to quality issues and optimization opportunities. Biometric monitoring will provide continuous tracking of individual animal health, behavior, and performance, creating comprehensive datasets that enable personalized management and early intervention. Environmental monitoring will track microclimates within facilities and pastures, enabling precise environmental control that optimizes animal comfort and performance while minimizing resource use. Automated response systems will react to sensor data faster than human operators, implementing immediate corrections for temperature, humidity, feeding, and other environmental factors that affect animal welfare and performance. Connectivity and communication will enable seamless integration of farm systems with external networks. 5G and satellite connectivity will provide high-speed, reliable internet access, enabling real-time data transfer and cloud computing capabilities. Edge computing will process data locally for immediate responses, while cloud integration provides advanced analytics and machine learning capabilities that require substantial computing power. Internet of Things integration will connect all farm equipment and systems for coordinated operation and comprehensive monitoring, creating integrated systems that operate as unified entities rather than isolated components. Cybersecurity systems will protect farm operations from digital threats while maintaining connectivity and functionality, ensuring operational continuity and data protection in increasingly connected environments. Software and platform integration will simplify complex system management. Unified management platforms will integrate all farm systems through single interfaces, reducing complexity and training requirements while improving operational efficiency. Predictive analytics will forecast optimal management actions based on historical data, current conditions, and projected outcomes, enabling proactive rather than reactive management approaches. Automated reporting will generate regulatory, financial, and performance reports automatically, reducing administrative burden while ensuring compliance and providing management insights. Integration APIs will enable seamless data sharing between different software systems and equipment manufacturers, creating interoperable systems that maximize technology value. Human-machine interface evolution will optimize the interaction between human operators and automated systems. Voice control and natural language processing will enable intuitive system control and query capabilities, reducing training requirements and improving usability. Gesture recognition and haptic feedback will provide intuitive control interfaces that feel natural and responsive, improving operator efficiency and satisfaction while reducing errors. Brain-computer interfaces will begin experimental implementation for direct neural control of farm systems, potentially enabling thought-controlled management for operators with disabilities or in specialized applications. Augmented human capabilities will enhance rather than replace human intelligence and decision-making, creating hybrid human AI systems that exceed the capabilities of either approach alone. Technology adoption strategies will focus on integration and value optimization. Phased implementation will introduce new technologies gradually to minimize disruption, while building capabilities and expertise systematically. Return on investment analysis will guide technology adoption decisions based on measurable benefits and payback periods, ensuring that technology investments deliver economic value commensurate with their costs. Training and education programs will prepare farm operators for technology-enhanced operations, ensuring that human capabilities evolve alongside technological capabilities for optimal system performance. Technology maintenance and support systems will ensure reliable operation and rapid problem resolution, minimizing downtime and maximizing technology value through professional maintenance and support services. Innovation partnerships will connect farms with technology developers for customized solutions and early access to emerging technologies, enabling competitive advantages and technology leadership. Research collaboration will contribute to technology development while gaining early access to innovations, creating mutual benefits for farms and technology developers. Data ownership and privacy protection will ensure that farms maintain control over their data while benefiting from technology services, balancing innovation benefits with privacy and competitive protection. Economic models will adapt to technology-enhanced operations through new cost structures, revenue opportunities, and business models that leverage technology capabilities for competitive advantage and improved profitability. Key insight: by 2035, technology will enable 70 to 90% automation of routine tasks while enhancing rather than replacing human expertise in animal care. The most successful operations will achieve seamless integration of AI, robotics, and quantum computing capabilities while maintaining focus on animal welfare and product quality. Success will require strategic technology adoption that builds capabilities systematically while optimizing return on investment and maintaining operational reliability.